Hello, in this video we're going to talk about parallel and perpendicular lines and how to write equations of parallel and perpendicular lines. So the first thing to know is just what are parallel lines. So parallel lines are lines that never intersect. They will go on forever, but they will never cross paths. The slope, and so that's just, these lines kind of look parallel. The slope is always the same. They always have the same slope. And you can kind of visualize that by just counting off. So like if I said, well, I'm going to start here and I'm going to go up and over and go the same distance up, I'd be going about the same distance over. And so you can see their slopes are the same. The other thing you might want to do with this video is to pull up either your graphing calculator. If you don't have one, then go to desmos.com and kind of play around with these equations of lines. That's an online graphing calculator. It's free. You can just type in, the equation and see what the graph looks like. Change the slope or the y-intercept and see what those lines look like and how they change. Perpendicular lines are lines that meet at a 90-degree angle or right angle. They have what's called, so let's write that down. So meet or intersect at a right angle. And remember, right is 90 degrees. And they have slopes that are opposite reciprocals. And we'll talk about what this means. A reciprocal can be defined as like kind of a short math way is A over B, then the reciprocal is B over A. Let's take a maybe more practical look at what this is or how you would think about it. The opposite in math means to change the sign. The reciprocal means to flip the fraction. And try to separate these. You'll probably remember them as being together, opposite, reciprocal, but it's really two different things. So opposite is change the sign, reciprocal is flip the fraction. And that's important as you get down the road a little bit more in your math career as well. It'll be confusing if you always tie opposite and reciprocal together, because sometimes you just take the reciprocal, but not here. Slopes of perpendicular lines have opposite reciprocal slopes. Okay, so let's go through it one more time before we move on, and we'll say it again and again, but parallel lines, things to remember, have the same slope. Okay, that's kind of nice because there's not as much work to do, right? If you know the slope of one line, you know the slope to its parallel line. Perpendicular lines have opposite reciprocal slopes. That means to change the sign. If it's positive, make it negative, negative, make it positive, and then flip the fraction. So parallel lines have the same slopes, or we'll say equal slopes. And lines with equal slopes are parallel. So when you write an equation, and this is, by the way, a very popular math question. You'll see this in maybe every single one of your like algebra, geometry, algebra 2 classes. Write an equation of a line that passes through this point, -3, -5, and is parallel to the line y equals 3x minus 1. And then we'll graph them. That's a good practice and also a good way to check your work. So whenever you write an equation of the line, we always want to find slope. So the slope is parallel to this line. This line has a slope of m equals 3. So our parallel slope, which we can use that little symbol for parallel lines, is also 3. And after we write the slope, we're just going to simplify this to write the equation. Because at this point, you probably already have seen how to write an equation of, we'll say, new line. So you have a slope, you have a point, you can write an equation. Here we will use y equals mx plus b form. So remember, this is my x and this is my y. So y is -5, m is 3, x is -3, and then I don't know what b is. But we multiply and then add 9 to get b is equal to 4. So y is equal to 3x plus 4. Okay, and then we can graph this line. This has a y-intercept of 4. 1, 2, 3, 4. And then I go up 3 over 1. If I want to go the other way, I can go down 3, left 1. And I can compare that with my other line, which was given to me with a y-intercept of -1. And if I go up 3 over 1, I can go down 3 over 1. And you can see, especially by counting these out, that these lines will never intersect. My line got a little not straight there. Use a straight edge if you can. But they're not going to intersect. They are parallel. They look parallel, which is good. In terms of checking work, my slope was positive on both of them. My lines are going up. That's good. You can check y-intercepts too, -1 and 4. Those look great. Okay, so perpendicular lines. We already said this. They have slopes that are opposite reciprocals. And lines who have slopes are opposite reciprocals are perpendicular. Okay, so this says determine which of the following lines are parallel or perpendicular. Okay, well, how do I know if a line is parallel or perpendicular? I just have to look at the slope. If the slope is the same, it's parallel. If it's opposite, reciprocal, or a different sign, flip the fraction, it's perpendicular. So really what you have to do is find the slope for line A, B, and C. So pause the video and do that, and then we'll look at it together. So for line A, the slope is 5. It's already in y equals mx plus b form. For line B, excuse me, I need to get y by itself. So I have 5y is equal to -x plus 2. And then when I subtract x over, and then divide both sides by 5, and divide everything by 5, to get y is equal to -1/5 x plus 2/5. Okay, so my slope is -1/5 for line B. And then line C, I'm going to go ahead and add 2x over to get y by itself, and then divide by -10. So y is equal to, and this reduces to -1/5. 2 goes into 10 5 times. So there's my equation. What I really want is my slope. Okay, so you can see that line B and C have the same slope. So that means they're parallel. So B is parallel to C. And those are the symbol for parallel lines, just two little parallel lines. You can write them up and down too. So B is parallel to C. And then A, 5 is really 5 over 1. So the reciprocal of 5 is 1 over 5. And the opposite sign is negative. So that means A is also perpendicular to B. And since B and C are parallel, A must also be perpendicular to C as well. Or look at their slopes. They are opposite reciprocals of each other. So that's something that might be kind of interesting to think about is a line can be perpendicular to any number of lines, an infinite number of lines. And that's true for parallel lines too. There's an infinite number of parallel lines to every given line. Okay, so I would go ahead and pause the video here and try these on your own with writing the equation of the perpendicular line. Keep in mind the first thing you got to do is find the slope. So our slope here is 3. Our perpendicular slope, and this is the symbol for perpendicular, just two little perpendicular lines, is change the sign and flip the fraction. And then we'll do point slope form here just to see a different version of the line. We have slope, we have a point. So we have y, and then plus 3 is equal to -1/3. Whoops, I did 3 instead of 5. Let's change that 3 to a 5. Be careful that you don't get your x and y's confused. Excuse me. It is really easy to do in point slope form because the y comes second in the point, but the y comes first in the equation. And then x plus 3, remember to change the sign. To graph this line, start at the point given to you, -3, 1, 2, 3, 1, 2, 3, 4, 5, and then count off your slope. So you go down 1 over 3. Down 1 over 3. We'll try to draw kind of a straight line through that. And then let's compare that to our other line, which has a slope or a y-intercept of -1 and a slope of 3. So up 3 over 1, down 3 over 1. And when we connect these, if your thing is to scale, they should look like they form a right angle. And that looks pretty good because they do, and they're perpendicular. A couple things to note with this is if your tick marks are like off, it's not going to look like a right angle probably, or if your points are off somehow. The other thing is if you're using a graphing calculator, the TI-84 especially, it is not square screen. The screen's not square. So this won't look perpendicular unless you hit zoom, and then I can't remember what option it is, but scroll down to square. And that's a good way to get to a better window. Okay, pause the video and try this next one. Once again, we got to find our slope. So we start with m is equal to 3, and our perpendicular slope, again, is -1/3. And let's use y equals mx plus b this time around, just to do it a little differently than the last one. So we have x and y here. So 2 is equal to -1/3 times 9 plus b. And so when I multiply and then add 3, we get 5 is equal to, -9 here. So this would be +9. So subtract 3, and you get -1 is equal to b. So then your equation, y is y, m is -1/3, x is x, and b is -1. And it might be, did that kind of fast, so maybe pause that, think about that for a minute, or rewatch it if needed. And then we'll go ahead and graph this one. We have -1 and then down 1 over 3. Down 1 over 3. We'll try to draw a straight line through. Ooh, just missed a little bit there. And then -12 is not quite on the graph. We'll take it down a little further. And then we got to go up 3 over 1. So up 1, 2, 3 over 1. And if we draw a straight line through these points, then this should be a right angle, which it looks good. Other ways that you can check your work is just the slope of the line. This green line is slanting down, so it should be a negative slope, which is good. This blue line is slanting up, which means it should be a positive slope. So it looks like I did something right there. And in fact, I believe those are correct. Good luck with this, and reach out if you have questions.